Hello Math 95 students, this is section 12.5. This is about solving equations that have rational expressions in them. So the previous three sections were about how to simplify rational expressions by multiplying or dividing or adding or subtracting. But this is actually involving an equation, not just an expression. So notice, the problem has an equal to sign in it, right? That's the difference between an equation and an expression, is the equal sign. And when there's that equal sign and we're trying to solve, that means the goal is to get x by itself. So the new tool that you need to put in your bag for this unit in algebra is to be able to get everything off of the bottom of the fractions. We need to get everything off the bottom. If we can get the stuff off the bottom, then we can combine things and get x by itself. But as long as we have anything on the bottom here, then we're kind of stuck and won't be able to get it by itself. There's another way to do this, and that would be by using what you've learned before to get a common denominator here and combine these into a single fraction, get a common denominator here and combine these into a single fraction, and then cross multiply. That's another way to do it, and that's a totally good, fine way to do it, but I'm going to show you the way that I just described to you, which is to get everything off the bottom in order to solve the equation. So the way that you do that is you say, well, I have an x on the bottom here. So what does it mean when something is on the bottom? It means that that thing is being divided. So the way that you will get that off the bottom is to do the opposite of that, which is to multiply. So to get the x off the bottom, I'm going to multiply this term by x. Now, to do this in a mathematically sound way, as long as I do the same thing to all terms in the equation, then I'm okay. I can't just do it to one term. I've got to do it to all the terms in the equation. So I'm also going to multiply that 7 by x, and that 2 by x, and that 6 over x by x. Now, anything that has an x on the bottom that I'm multiplying by x is going to cancel out. Those x's are going to cancel each other out. Okay, so my next line is going to be this. It's going to be 7 times x. I'm going to write it over here, is 7x. And then since the x is canceled out, it's just going to be minus 4 equals 2 times x is 2x. And since the x is canceled here, it's going to be plus 6. And now this equation looks like something you've solved before. I mean, this is not anything that you didn't know how to do before you came into this class. So all you have to do now is get your x's together and get the x by itself. So I'm going to move my 2x over here with my 7x. I'm going to subtract 2x from both sides. So that cancels that out. That gives me 5x minus 4 equals 6. Then I'm going to get the x by itself by adding 4 to both sides. So that gives me 5x equals 10. Then I'm going to get rid of the 5 by dividing both sides by 5. And that gives me x equals 2 as my answer. Okay. One thing you need to do on these that's a little aggravating is sometimes when you're solving a rational equation, the answer that you get for x is not actually a true answer. It might be, it's called an extraneous solution. Extraneous means it's extra, unneeded information. So it'd be an extraneous solution. And what happens when that happens is that you end up getting an answer that if you plug it back into the original equation, it doesn't actually work. But the only time that happens is if you take your answer that you got for x and plug it into the original equation and you end up getting 0 on the bottom of one of the fractions. Now that obviously doesn't happen here. If you plug in 2 for x, you don't get 0 on the bottom, you get 2. So that's not a problem here. So x really is the solution. But we got to keep that in mind when we get to the next examples. Okay, I'm going to take the same approach here. I'm trying to get anything that's on the bottom off the bottom. So maybe the first thing I'll do, and again, there's multiple ways to do this, but maybe the first thing you can think about doing is, I want to get that 4 off the bottom. How do I get it off the bottom? I multiply by 4 on that term. But if I do it on that term, I have to also do it on this term and this term. Okay. Now what happens? Okay. Now, those 4's cancel out, and those 4's cancel out. And actually, even on this term, the 4 and the 2, they don't cancel, but they do reduce. They reduce each other. So the 4 over the 2 will reduce each other by dividing both by 2, so that that 2 becomes a 1, and that 4 becomes a 2. Okay, so my next line will be, since the 4's canceled out here, it's going to be x minus, okay, what do I have going on here? 3 times 2 on top, that's 6. What do I have on the bottom? I've just got x. If you say 1x, that's okay also, but I'm just going to put x. And what do I have here? Since the 4's canceled out, that's going to be 5. Okay, again, I'm trying to get everything off the bottom. I got something off the bottom in the first step, but I still have something on the bottom here that I've got to now, in the second step, get that thing off the bottom. What do I have on the bottom here? I have an x. Well, how do I get that thing off the bottom? I multiply that term by x. So then I have to multiply that term by x, and I have to multiply that term by x. Okay, the x on the bottom and that x right there, they cancel out. So what do I have? X times x gives me x squared, minus, since the x is canceled, that's going to be 6. And that's going to equal 5 times x is 5x. Okay, now this is an equation that you have solved before in this class. There's nothing left on the bottom. We can kind of do what we already know, the things that we already know to do. This is a quadratic equation since it's got the squared exponent. So the way that you're not going to be able to get the x by itself using the good old Algebra 1 skills you've had in the past. What you got to do is you got to get all the terms on the same side and then see if you can factor or do the quadratic formula. That's what you have to do when you have an x squared term and an x term. So I'm going to move the 5x over to the side, this side with the other two terms by subtracting 5x from both sides, which then gives me, I'm going to write it like this, x squared and then minus 5x and then minus 6 equals 0. Then you have to factor. I believe this will factor. It will factor as x minus 6 and x plus 1. And so then when you solve both of these, you get x equals positive 6 and negative 1 when you set both of them equal to 0. Okay, now I do need to check, like I said before, to see if either one of those, if you plug it back into the original equation, does it make the denominator become 0? And it doesn't. If you plug 6 in, you don't get 0 on the bottom. If you plug negative 1 in, you don't get 0 on the bottom. So both of those are good. They are really true answers to that equation. Okay, I'm taking the same approach. I'm trying to get anything that's on the bottom off the bottom. So right now I have a w minus 3 on the bottom. How do I get w minus 3 off the bottom? By multiplying this term by w minus 3. I probably need to spread this out more so you can kind of see more of what's really happening. Let me spread it out. Okay. So what I'm doing is I'm multiplying this whole term here. Multiplying this whole term, all right, by w minus 3. And I'm multiplying the 2 also by w minus 3. And I'm multiplying this whole term by w minus 3. So what happens? The w minus 3 cancels with the w minus 3 on the bottom. The w minus 3 here also cancels with the w minus 3 on the bottom. So what have I got? I've got, since the w minus 3 canceled, I've just got 4 plus, and now here I have to distribute the 2, right? I have to distribute the 2. So if I distribute that 2, I get 2w minus 6. And then here, since the w's minus 3 is canceled out, I've just got w plus 1. Now it's just a matter of combining like terms and getting the w by itself. So I'm going to go ahead and combine the 4 and the negative 6, and I've got 2w minus 2 equals w plus 1. I'm going to move my w over here with my other w term, and that's going to give me 2w minus w is w minus 2 equals 1. Then I'm going to add 2, and I'm going to get w equals 3 as my answer. Let's look back and make sure that that is not going to mess up the equation if we plug it back in. What if we plug in 3 into the original equation? If I plug in 3 for w in the original equation, does it make me have 0 on the bottom of a fraction? Yes, it does. If I plug in 3 for w, that gives me a 0 on the bottom. And remember, you can't divide by 0. It becomes a whole undefined expression, a whole undefined value. So that's not a true solution to that equation. That's an extraneous solution. So that, even though it looked like it might be a solution, it is not. So really, since 3 is the only possibility and it's not going to work, then there is no solution. Okay. Next example. I'm going to spread it out a little bit. Okay, same strategy. I'm trying to get everything off the bottom. So the first thing to get off the bottom for me is the x minus 3. If you want to get the x plus 1 off the bottom first, that's fine too. But I'm just going to go ahead and get the x minus 3 off the bottom. And how do I do that? By multiplying that whole term, that whole fraction there, by x minus 3. But then I got to do the same thing to this whole thing over here. So what happens now is the x minus 3's cancel there. So that just gives me x plus 4 equals, it doesn't cancel here, so I've got to distribute everything. I got to do the full method here. I got to distribute everything. It's going to give me x squared minus 3x minus 6x plus 18 over x plus 1. All right, let me clean that up a little. It's x plus 4 equals x squared minus 9x plus 18 over x plus 1. And now, what have I got to get off the bottom now? I have to get the x plus 1 off the bottom. So I've got to multiply that whole fraction right there by x plus 1. And that means I'm going to have to multiply everything over here by x plus 1 too. The easiest way to do that is just to put parentheses around the whole expression there and multiply that whole expression by x plus 1. And now I have to distribute here. But what happens on the right side, just real quick, is that the x plus 1's cancel out, just like they've been doing. So that gives me, on the left side, it gives me x squared. I'm going to write it real small. X squared plus x plus 4x plus 4. So that's going to be x squared plus 5x plus 4 equals x squared minus 9x plus 18. Now, just get all your terms, like terms together. I'm just going to go ahead and subtract x squared from both sides. And I'm going to go ahead and add 9x to both sides. I'm kind of trying to do all this in one step. save a little time, and go ahead and subtract 18 from both sides as well. So I'm moving all three of the terms from the right side over to the left side. So what happens? Everything's canceling over here, obviously, but over here, what happens? The x squareds cancel over here also. X squared minus x squared cancels out. That's 0x squared, so it's gone. What do I have then? 5x plus 9x, that's 14x. 4 minus 18, that's minus 14, equals 0. Just get x by itself now by adding 14 to both sides. So 14x equals 14. Now divide by 14. And x equals 1 is my answer. But I got to go check it. I got to make sure that plugging 1 in for x doesn't make the bottom of that fraction be 0. Well, if I plug 1x into the left one, I definitely don't get 0 on the bottom. If I plug 1 into the right one, I don't get 0 on the bottom either. I get 2. 1 plus 1 is 2. So 1 is a good answer. That's a good answer. All right, let me spread this out. X over x minus 5 plus 2 over x minus 6 equals. Now, what do you think we might do with the bottom right expression? Take a guess. Maybe you guessed it. We're going to factor it. If we have these expressions on the bottom where it's possible to factor them, then go ahead and factor them. Like the x squared minus 11x plus 30, I'm looking at that and I'm automatically thinking, wait a minute, that looks like it'll factor. So I'm going to go ahead and factor it. That's going to factor as x. See if you can do it. X minus 5, x minus 6. All right. Now I'm trying to get everything off the bottom. So the first thing I might get off the bottom is the x minus 5. So I'm going to multiply this term by x minus 5. And I'm going to multiply this term by x minus 5. And I'm going to multiply this term by x minus 5. So what happens? The x minus 5's cancel right here. And the x minus 5's cancel right here also. So what do I have now? I have x plus that 2 has to distribute to that x minus 5. So 2x minus 10. You might be wondering, why doesn't the x minus 6 multiply with the x minus 5? Like, why doesn't that x minus 5 get multiplied by the 2 and by the x minus 6? Well, the reason is because when you're multiplying fractions, you multiply straight across. And I have this x minus 5, and it's over 1. Like anything that's not already over something, you can pretend like it's over 1. So the x minus 6 really just multiplies with the 1. Sorry about that. Where did we go? There we are. That's why the bottom is not multiplying with it, only the top is. So it's 2x minus 10 over x minus 6 equals, the x minus 5 is canceled, so I've got 2 over x minus 6 here. Now, what am I getting off the bottom? I'm getting the x minus 6 off the bottom. So I'm going to multiply this term by x minus 6 and this term by x minus 6 and back over here at this term also by x minus 6. So the x minus 6's cancel here and they cancel here. But I do need to distribute there. That gives me, what's it give me? It gives me x squared minus 6x plus, here I'm just left with 2x minus 10. Equals, here I'm just left with 2. Combine all your like terms. It's going to be x squared minus 4x, and I'm going to go ahead and move that 2 over here. I'm going to go ahead and move the 2 over to combine it with that minus 10, so that's going to give me minus 12. Let me get my regular color there. Minus 12 equals 0. And now, what do you think we're going to do? If possible, we're going to factor, aren't we? That's kind of the simplest way to solve these, if possible. These quadratic equations. So go ahead and try to factor it. It is x minus 6 and x plus 2. So if I solve both of these by setting them both equal to 0, I'm going to get positive 6 and negative 2 as my answers. Let's go back up and see if both of them work. Oh, I see one that won't work, don't you? Already? If I plug 6 in, 6 minus 6 gives me 0 there on the bottom. So that's not going to work. The 2 though, the 2 will work. 2 doesn't hurt anything here. So the 6 is not really an answer, but the negative 2 is an answer. The negative 2 is a good answer. Okay, this is a little bit different looking problem, but we're going to end up doing some of the same stuff we've been doing. It says let f of x equal this expression right here, and then it says find x when f of x equals 1. So that means I'm looking for x. I'm going to plug 1 in for f of x because it says when f of x equals 1. So I'm putting the 1 in the place of the f of x. And I'm going to solve for x just like I've been showing you how to do. Notice I'm leaving a little space between these, more spaced out than the original problem had it. Okay. One thing that's going to be a little tricky on this problem is the fact that you have a minus sign right here. In fact, I think what I would recommend doing, at some point you're going to have to distribute that minus sign to all the terms that come after it. So maybe you could go ahead and do it now. If you don't go ahead and do it now, you're going to have to do it after we get rid of the denominators. But let's just go ahead and do it now to be safe. I think might be the safest thing to teach you to do. So I'm going to go ahead and make that minus into a plus, and I'm going to change the signs in the top of the fraction that comes after it. So it's going to become a negative x and a positive 2. Okay. Now let's go about getting everything off the bottom. So the first thing I get off the bottom here would probably be the x minus 3. So multiply that term by x minus 3 and this term by x minus 3, and back over here at this term also by x minus 3. So the x minus 3's cancel there. So what do I have on the left side? I've got 1 times x minus 3, so I distribute the 1 and I get x minus 3 equals, the x minus 3 is canceled, so I've got x plus 1 plus, here I have to distribute, so I'm going to distribute this like so. So negative x times x, I'm going to do it small up here first, is negative x squared. Negative x times negative 3 is plus 3x. 2 times x is plus 2x. And 2 times negative 3 is negative 6. So let me combine like terms, and I've got negative x squared plus 5x minus 6. Okay, and that's all over, still over x plus 3. Still got that x plus 3 on the bottom there. So now I have to get the x plus 3 off the bottom. So I'm going to multiply this whole term by x plus 3. And probably the easiest way to multiply the other terms by x plus 3 is to just put that x plus 1 in parentheses and multiply it by x plus 3 by distributing. And the same thing here, put that x minus 3 in parentheses and multiply it by x plus 3 by distributing. Okay, so the x plus 3 cancels here. And so I have to distribute here. I'm going to write it small. It's going to be x squared plus 3x minus 3x minus 9. And here, so that's going to be x squared, 3x and negative 3x cancel. So it's just going to be x squared minus 9 equals, here I've got x squared plus 3x plus x plus 3. So that's x squared plus 4x plus 3 plus negative x squared plus 5x minus 6. Now if you just wrote minus x squared instead of plus negative x squared, that's totally fine. That's the same thing. Okay, now what happens? I'm going to go ahead and combine all my like terms over here on this side. So that gives me about x squared minus 9 equals x squared or negative x squared actually cancel each other out. 4x and 5x. 5x makes 9x, and 3 and negative 6 makes negative 3. Now I've got to get all my terms on the same side, and since it's a quadratic equation with an x squared and an x, the best way to do it would be to either factor it or do the quadratic formula. So I'm going to move my 9x, and I'm going to move my 3 by subtracting 9x and adding 3 to both sides, so it cancels here. That gives me x squared minus 9x, and the negative 9 plus 3 makes minus 6 equals 0. And I believe that will factor as x minus 3. Let me think. No, it actually won't factor. If the 9x and if that 6 was a 9 and that 9 was a 6, it would have factored, but this one won't factor. So if it won't factor, what do we have to do? Negative b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac over 2a over 2a. Yep, quadratic formula. So negative 9 plus or minus the square root of negative 9 squared minus 4 times 1 times negative 6 all over 2 times 1. So that's going to be negative 9 makes positive 9 plus or minus the square root of 81 plus 24 over 2. So that's x equals 9 plus or minus the square root of 105 over 2. Let me see if 105 will break down. I'm not sure, but I'm going to try. 5 times 21 and then 7 times 3. So I don't have any pairs. So the 105, the square root of 105 will not break down to anything simpler. So I'm just going to leave my answer just like that. And that's a good answer. Those are my two answers for x. And certainly neither one of those strange irrational numbers will make the original denominator be 0 at all. So that's the answer to this problem. That is x. Those are the values of x when the value of that function equals 1. That's all the examples for 12.5. So 12.5 is done. I do want to go back and show you one problem from 12.4. 12.4 is nothing new. We've already done things like 12.4. It's just that the problems are written differently. It's the same thing we learned in 12.2. It is how to divide fractions. So all we have to do is take that fraction and the top fraction. Remember, to divide, you keep, change, flip. So I keep that. I change the fraction bar to multiplication. I should say change to multiplication. And the bottom fraction, I flip. Okay, so keep, change, flip. So all I do is keep the 8 over 7x the same, make it a multiplication problem, and flip the 4 over 5x to make it be 5x over 4. And so now what happens? You can simplify things like the x and the x can both cancel out. The 8 and the 4 can reduce each other by dividing both by 4. So that becomes a 1 and that becomes a 2. And so now my problem is 2 over 7 times 5 over 1. So it's just 10 over 7 as the answer. So I just wanted to show you one example of that, just because you may have a problem like that on the test, but it's the same exact thing we did before. It's nothing new. So I didn't want to do a whole new section just over stuff like that. Good luck on your assignment on 12.5. I'll see you again in chapter 13.